Good morning. Welcome to Air Curtains, Reducing Airborne Pathogens and Improving Indoor Air Quality. I'm Scott Arnold, Senior Manager of Publications and Standards for Air Movement and Control Association International. On behalf of our more than 400 members worldwide, I want to thank you for joining us. We realize there's a lot to see and do at the AHR Expo. We respect and value your time and hope you find this educational session worth your while. The information contained in this session is provided by AMCA as an educational service. In making this educational activity available, AMCA is not endorsing, sponsoring, or recommending a particular company, product, or application. Lastly, this session is protected by U.S. and international copyright laws. Reproduction, distribution, display, and use of the material without written permission from AMCA International is prohibited. And with that, let's meet our presenter. The Director of Engineering for Mars Air Systems, Naga Thiagarajan, has extensive academic and working knowledge of the design of air curtains and the proving of their effectiveness using both computational fluid dynamics modeling and physical tests. He has led dozens of learning sessions and worked closely with architects, engineers, and contractors. Naga?
Thank you, Scott. Good morning, everyone. Thanks for coming here today. Today we're going to learn about what an air curtain is and how it operates. We're going to touch on the typical applications of an air curtain and different types of air curtains that are out in the market today. And after that, we're going to do a dive into how an air curtain can improve indoor air quality. We're going to talk about some of the technologies that are available and also identify some potential applications and where you can use an air curtain to improve the IAQ. I don't think anyone in this crowd needs an introduction of what indoor air quality means, but I have a couple of images here to drive home the point. The image that you see on the left side is smog and vehicular pollution. This is actually downtown LA. It's pretty typical for any city. And the one on the right side is the wildfire smoke. That's actually New York. Okay, that is New York. Now, wildfire is becoming more and more common, and indoor air quality is also becoming a bigger criteria for a lot of people to look into. Okay, air curtain is a device which blows air across the entire width of the opening and the height of the opening. That's essentially what an air curtain is. Of course, there are other properties for the airflow to meet to be as effective as what it could be. Properties like uniformity, that is, you should have uniform airflow across the length of the unit. You should have the right amount of airflow at the floor level. If you're trying to use it for thermal separation or for flight control, you need to have the right amount of airflow. You need to have laminar airflow and so on. That's what makes an air curtain. Okay. When you don't have an air curtain on an opening, typically the air moves from one side of the opening to the other side because of the difference in temperatures from the inside to the outside. These temperature differences cause thermal forces because the hot air inside the room rises up, creating a partial vacuum at the floor level. Exact opposite thing happens on the outside. The cold air, heavier sinks to the floor, comes into the opening, which due to the partial pressure, and that's how the stack of it happens, and air moves from one side of the opening to the other side. Air curtain works by the principle of entrainment, tries to separate these two zones. In an ideal situation, about 75% of the transfer of movement is contained by use of an air curtain. Okay, I can say whatever I need, but here are some CFD analysis. The one image that you see on the top left side, it's a vestibule with two doors open to the outside, which is cold. The left image is with no air curtain, and the image on the right side is air curtain. It's not 100% effective, but if you compare the two situations, there is a pretty decent separation there. The color images that you see on the right side is a cooler with a thermal imaging gun. You can see the pink lighting, which is the cold air leaving the cooler from the bottom. And the graph that you see is an average of temperature probes inside the cooler. Now, there's a whole bank of temperature probe. The green line is the average temperature inside the cooler went up from about 45, 42, 43 to about close to 60. The blue line is when the air curtain is on. Still not 100% effective, but definitely there is pretty decent separation. Okay. Here is a little chamber that we built to test different orientations of an air curtain and also to do show and tell. It's a smoke machine blowing into a glass chamber. I don't know whether you can see there is some infiltration through the opening, but most of the smoke is being stopped by the air curtain. Okay. Again, these are some of the tools that we use to educate our potential customers. There are different types of air curtains. Broadly speaking, there is non-recirculative type air curtain where you have an air curtain. It blows on the floor or the wall, and then the air curtain splits after it sees the surface. And then there is recirculating air curtain. Recirculating air curtain has a discharge on one side and suction on the other side. Probably might have seen in Costco's in the cooler and freezer sections. Very popular in cold storage applications, but really got to do nothing with indoor air quality. That is mostly for thermal separation. The scope of this presentation today for indoor air quality deals completely with non-recirculating air curtains. And I'll explain you why that is what is needed for improving indoor air quality in a little bit. Here are some typical applications. You can install air curtain above the opening and blow straight down, at a slight angle, or if your opening is very tall, if the aspect ratio is too high, where the height is much more taller than the width, you can have a smaller air curtain installed vertically on the side of the opening and blow from the right to left or left to right. From an effectiveness standpoint, it's going to be pretty much the same. We have high velocity air curtains for large openings, low velocity air curtains for smaller openings. We also have recessed air curtains. Since for indoor air quality, we're going to be using different technologies like filters, UVs, and whatnot. Very high velocity air curtains are not really applicable because the pathogens need to see the UV. When it comes to cleaning the indoors air quality, low velocity air curtains is the way to go. Okay. Again, how does an air curtain help in indoor air quality? There are three different ways. Forming a physical barrier. Air curtains are pretty good in stopping the flies and dust from coming into your indoor space. Okay. It is also good in stopping vehicular smoke and any kind of smoke that is outside from coming into your space. Okay. Filters are very popular. There are many different types of filters used in many HVAC systems, including air curtain. And lastly, eradication. You have UV and ionizer, other technologies which can be used to clean the pathogens inside your room. Okay. Air curtains with these technologies have been around for over 20 years. Okay. But it became really popular in 2019, 2020 after COVID happened. But there has been a lot of research, a lot of publications out there. These are some of the ones that I liked. Influence of optimized air curtain as subway entrance to reduce airborne particles, analysis of fine particulate matter by blocking effect of air curtain through experimental measurements, measurement of air curtain on infiltration of airborne particles through an opening. That is actually an ASHRAE conference paper. And then maintaining indoor air quality is an AMCA in Motion magazine. And lastly, the one that I have there is air curtain as a barrier for smoke in case of fire. It's a numerical modeling though. Okay, but Google it up. These papers are available online, so if you want to take a read. Here is some of the experiments that we have done in our factory. This is our conference room. We have this smoke machine blowing directly at the opening. You can see there is air curtain on the top. So you see the white nozzle on the top of the opening. That's the air curtain. In this case, the air curtain is installed outside. And we also have a little prop fan trying to push the smoke into the chamber. So we tested many different configurations. And the photograph that you see on the right side is the same image, but the photograph is taken from the inside. So you can see the smoke is stopped at the opening itself. And we had particulate sensors inside, outside, multiple locations. And here is the graph that you see is PM 2.5 particle size. Blue line is the concentration inside the room with the air curtain on. The red line is the same, but with air curtain off. You see it's not 100%, but about 50% of the particles have been reduced just by having an air curtain. Nothing special in the air curtain. It doesn't have any of the technologies, but it stops the smoke from coming in exactly like what it would do for thermal separation. Again, what I say is air curtain is not a replacement to a physical door. You see this graph here when an air curtain was working with an actual door. We had an actuator closing and opening the door, had different cycles. But if you don't have a physical door, air curtain is not going to do much. And then from an eradication standpoint, actually we had some very good encouraging results. We tested air curtains for thermal separation in one of the restaurants close to our factory. And they had a cooler. They were kind enough to give us access to the cooler to do some studies from a temperature separation standpoint. And we thought, why not even use petri dishes in different areas of the cooler, put UV on and see what happens, right? And this was our result. So we had petri dishes in 3 or 4 different locations. The top 3 images that you see is in the cooler with UV on, and the bottom 3 image is the petri dish with the UV off. Okay, that's the only difference. The fan was running in both scenarios, or the air curtain was running in both scenarios. In all the 3 locations, within 7 days of incubation, you can see the amount of mold that was growing. And even after 14 days of incubation, we didn't see any mold growth when the UV was on. It's a pretty small size cooler. It's probably like 10 by 10 size cooler. It's not a large cooler, but still it's a pretty encouraging results. In fact, we also sent the petri dishes to a lab to find out what these mold means. It's penicillin. I'm not sure what that is, but what I do know is not harmful for humans. Okay, but that is a pretty encouraging results for us. So this actually led us to go to the next step. So we built this custom chamber in our factory. It's 2 chambers put together. You have temperature controlled on both sides of the chamber. We have an air curtain with UV on both chambers. One side has a UV, another side just has the air curtain. It's a small air curtain just to see, how efficient it is in eradicating airborne mold spores and so on. We tried different types of fruits and vegetables and food source. Strawberries were some of our most successful candidates so far. Again, the top 2 images that you see is after 4 days of exposure. The strawberries is not seeing the UV light directly. All it does is the air is being processed through the air curtain with UV on. The top 2 images is for the strawberries. When the UV was on, you see there is no mold growth. But on the other side, when the UV was off, you could see mold growth within 4 days. And all the white stuff that you see is the mold. We continued the testing. Here you see, again, the top 3 images is when the UV was on, the bottom is with no UV. You can clearly see that strawberries did shrink because it's about 75 degrees in the cooler when we started doing these tests. Clearly within 2 days, you can see some mold growth here. And even after 13 days, there is no mold growth. The strawberries dried up, but there's no mold growth on the side with UV on. Really encouraging results for us. So that's the reason why we upgraded the testing by adding ACs and all that to try to simulate real cold storage. Next thing is what kind of technologies that are available that can be used with an air curtain. Filters, obvious thing, right? We've been using filters with air curtains forever. UV lights, again, it's a very old technology. We've been using that. And the ion generator. So these are the 3 things, in my opinion, that can be used with an air curtain, not only to use as a thermal separation, but also to improve the indoor air quality. In fact, even ASHRAE has TC 5.3, which talks about room air distribution. During COVID, they did encourage to use any of these technologies with existing HVAC systems. And that's when we already had a device that can slap onto existing air curtains to include filtration or UV and whatnot, and all those technologies. Okay. All right, let's talk about filters first. The image that you see on the bottom just gives you a visual representation of this to compare the size of the particles that are present in a normal indoor space. 100 microns is our hair. Most of mold spores is about 30 microns. But recently, I just learned from one of the booths here is mold spores can go down up to 3 microns. So the size really can vary. Household dust about 10 microns, cat allergens about 5 microns, tobacco smoke at 1 micron, and so on, right? We have different types of filters. The most common filters are MERV rated filters. For those of you who don't know what MERV ratings is, it's a rating by ASHRAE. The higher the rating, the more capacity to trap smaller particles. Okay. If you see the third column, it does say, for example, if you're looking at a MERV 10, 1 to 3 micron particles can be captured at 50 to 64% effectiveness. Okay, so you got to see both. You got to see what size particles that can be captured, and also the efficiency or the effectiveness of the filter itself. And another important factor that's not there in this graph is also the airflow. So most of these filters can capture these particles only if the airflow is at or below a certain CFM. If the air moving through the filters too fast, these numbers doesn't mean anything. Besides MERV filters, we also have HEPA filters and ULPA filters. So the COVID virus itself is about 0.1, 0.12 microns in size. Okay, none of these filters can capture the COVID virus by itself. But the COVID needs an accelerant. It needs fluid droplets to spread through the room. Okay, those droplets are typically between 3 to 5 microns. And even the MERV-rated filters can capture that. The effectiveness is a little lower, but the HEPA filters can capture up to 0.3 microns and 99.9% effectiveness. Okay, and if you want to go even further, we also have something called the ULPA filters, which can capture 0.12 microns. Just remember, the more the filtration capacity of a filter, the lower the airflow it's going to see. So an air curtain, which is typically installed over an opening, it needs to have certain amount of airflow so you can reach all the way to the floor level. If you keep increasing the size of the filters, the primary function of an air curtain will be sacrificed. And that's the reason why what we do is we make the filters as big as possible so it can process more air. Okay. Here, this is pretty much the same thing with it, which I just said right now. The speed of the air for most of these filters should not, the phase velocity should be between 3 to 500 FPM max. Okay. Again, these filters are really good in capturing, very tiny particles. Make sure you use some kind of a good pre-filter. If you go back to the slide here, so you have the air curtain on the bottom image all the way on the right, HEPA filter, and a MERV filter. Typically, MERV 8, MERV 10, MERV 13 filters are used as pre-filters. Really depends on what kind of pathogens you see. Most of the manufacturers will offer MERV 8 filters as for pre-filters. The HEPA filters are pretty expensive because it's custom made. So if your area is going to see more dust or more finer particles, try looking at a different MERV filters. And these are off-the-shelf filters too. You don't have to buy it from the original manufacturers. You can go to Grainger and buy it for the most part. Okay. Next is UV. The sun is the biggest source of UV. UV is just a different frequency that is outside of the visible light frequency. There are 3 different types of UVs generated by the sun, UVA, B, and C. UVA comes through the ozone layer. UVA is having the higher frequency. When you compare among the 3, UVA is higher. UVB is slightly smaller frequency than, shorter frequency than UVA. UVA can penetrate through our skin. It really is not that harmful, but it does cause aging and wrinkles on the skin. UVB can only penetrate the outside layer of the skin, but again, it can cause sunburns, and if you're in some instances, it can also cause skin cancer. But UVC is the one that's dangerous for us. Fortunately, the ozone layer blocks all the UVC. We don't see any UVC on the surface, but UVC can easily be generated using a UV lamp. Okay, it should not be exposed to skin. It will damage the DNA. It will cause all kinds of issues. I've seen in a lot of bathrooms, this where you can dry your hands. You have a blue light. That's not UV. That's just blue light. Okay. In fact, I've also seen UV offers in bidets. So not sure what people thought when they bought that. Again, UV is not a new technology. It's been there forever. It's been there since 1930s. UVC is the one that's critical for us. The frequency is about 254 nanometers is the frequency for that. And the way it kills pathogens is the frequency is ideal, so it can damage the DNA and it'll stop the cells from growing. Okay. You have the image on the left side. UV is used in front of filters. This is actually a pretty good application. This is not an air curtain, but this is just another application. Filters are really good in trapping small particles and even fluid droplets. UVs shining on filters will kill any mold growth or any kind of pathogens that is growing in the filter. So it's a pretty good application. It's been widely used for many, many years in hospitals and in hot water coils and other many different industrial applications as well. Besides UV, then you also have the ionizers. There are many different types of ionizers. The idea really is, they produces positive and negative ions. They can go and form a cluster around any particles that's there in the air. Typically, something alive, like an airborne pathogen, and then it becomes heavy, sinks to the surface, floors, and once you wipe it off or clean it, it can remove most of the pathogens. It also, since it's charged, it can also remove the hydrogen molecules from the pathogens and thereby neutralizing it in some instances too. Okay. Again, there are many different types of ionizers. The only thing I would recommend is most of the ionizers, even some of the UVs, they also produce ozone. Okay. Ozone is pretty crucial. That is mandated by different codes. If you should have there's a limitation on amount of ozone that any of these technologies can produce. Keep in mind, if you guys are using it or if you're getting it from another manufacturer, make sure you keep an eye on that, okay? And you can smell ozone. If it's there in the air, you can smell it too. Next is proper selections and applications. The image that you see here is having all the three technologies. It's got the ion generator, UV lamps, HEPA filter, and MERV-8 pre-filter, at least in this image here. Really, when you're trying to use any of these technologies, you need to know your application. What is it that you're trying to solve? Is it, are you trying to prevent dust from coming in? Are you trying to stop some kind of mold spores growth? Or if it's a waiting area, cafeteria, something like that, where a lot of people congregate, you need to know what you're going to try. What are you trying to solve? Okay, I think that's the first thing that you need to look at. After that, you identify that, then you can look at what kind of technologies that you need. Do you need UV? Do you need a custom sequence of operation where the fans are running on a 24/7 timer or some kind of a cycle timer? Or you need filters, HEPA filters or ULPF filters or some things like that. Okay. And after you select what kind of technology you need, the next thing you need to know is what's the size of your room? How many people are going to be in this room at the same time, right? Good starting point will be the manufacturer's website. Now, most of these providers, they'll have some kind of a guideline. For example, that you see here is 15 passes, or a packet of air that's been passed through the UV system 15 times. In our testing, that's a good starting point for us. Okay. Again, just look at the CFM of the air curtain, and then the size of your room, and then you can calculate that. Okay, we look for custom sequences too, because you might want to use the air curtain at an entrance where when the door opens, the fan goes to full speed, providing separation, and when the door closes, the fan will go to low speed, constantly sanitizing the indoor space. Okay, and you need to know what the speeds are. As long as you know the fan RPM, you can calculate what the CFM is going to be at the lower speeds, and you know how long you need to run the fan, depending on the size of your room. But also keep in mind, most of these graphs or any information that's given is on a room where new pathogens are not going to be introduced. But if you have a room like this where pathogens are going to be introduced constantly, then you need to run it for a longer time or get a fan with more CFM. Here are some applications. This is an industrial distribution center. You have loading docks, you have office, you have a little staging area. You have different types of doors. The one that you see for the loading docks, probably they are like 14 feet or 16 feet tall doors. I don't think any of these technologies is going to work. You can look at filtration if that is required, but really those needs a lot more airflow. Again, you got to identify, is that the area that's going to produce pathogens for me? Is that the area that's going to produce dust? If yes, then you can put air curtains on the other smaller doors. In fact, you can also put an air curtain on a stationary wall, which is constantly running, sanitizing their room. Okay, and same thing, maybe in this application, the waiting area is probably a better area to look for sanitation. Here is a bus garage. Again, if you have something like this where a lot of people are going to keep going in and out, that's fresh introductions of pathogens or dust or whatnot, because it's a high traffic door. The doors are going to be open for much longer. Here you can also see if you have a poorly designed HVAC system, right? Or you might have some areas where you will see stagnant air. You don't have to use an air curtain at an opening. You can also slap it on in the corner. What it does is not only sanitizes the air, it also moves the air across through the room. Your existing HVAC system take care of all the air in the room. Okay. Here is another application, things like where a lot of people are going to congregate, like break areas, dining areas, locker areas. You can have air curtains with these technologies on a wall, or you can have it vertically standing on one of the corners, or it can also be on a table. Okay, there are many different types of options. In fact, very recently I also saw these kind of products offered in IKEA. They have an HEPA filter. So it is becoming much more popular right now. Some other important considerations is pretty much any fan, any air curtain that you buy, it's all going to be ETL or UL certified. If you're buying air curtains with filters, that might be one thing. But if you're trying to get an air curtain with UV technology, which has its own control system and all that, make sure the whole product with those control systems are UL or ETL certified or CSA certified. That's something I would recommend you keep an eye out. Okay. Some of the common questions I've heard is, does the UV work or does the filters work? The only way you can positively say it is working is by having a sensor, some kind of a sensor in your room. You can get a few $100 worth sensor, slap it on the wall, check what it was before and what it is after. Or you can get a handheld, more expensive device to check. Or another crude way to tell is if you have filters, see how often the filters are getting clogged, how often the filters are getting dirty. That shows that the system is working, right? Or if you have people with allergies, you can find out whether the allergies go away before and after. So that's another way, indirect way of saying that the system works. But again, there is no easy answer. Also keep in mind, if you can have the best system in the world, but if you keep having fresh introductions of outside air or smoke or other pathogens, there's only so much any system can do. Again, in my opinion, an air curtain is another layer that you can add to your existing system. You just can't rely only on this. Okay. To summarize, an air curtain forms a shield at any entrance, prevents for the outside air from infiltrating into your conditioned space. It does a great job in keeping the smoke and dust and debris outside. You can use the technologies that we discussed today to leverage the air curtain, make it better for sanitation once the door is closed. Thank you all. Sure, go for it.
So air curtains would be good for blocking things like bugs and maybe sand from outside. How would they affect heat transfer through a door at all? Like say you had it warmer inside, colder outside, would having an air curtain change how quickly the inside and outside of the door would equalize the temperature?
So your question is when the door is closed?
Well, if the door is open and having an air curtain running at full blast, would it affect the way heat and temperature flows through?
Yeah, that is actually the primary purpose of an air curtain. When you have an opening, when the door is open, you're going to have migration of air across the opening. An air curtain, in an ideal condition, an air curtain is about 75% effective in minimizing that kind of a transfer.
So has anyone ever used an air curtain for maybe internal zoning within a building, like to try to do a sort of bonus type of zoning to try to have maybe two different rooms at different temperatures?
Yeah, they have done. I recently spoke to a gentleman who they make some kind of medical. They clean some medical equipments. They test in one zone, clean it in another zone. They wanted to form a barrier. What I say is an air curtain is not a replacement to a physical door.
Oh yeah.
Okay.
Would it help? Would it be better than nothing at all?
That's true, provided the pressure on both sides is balanced. Okay, and you need to have the right amount of airflow. If you have too much airflow at the floor level, it's going to split and you're going to have turbulence, right? So you just have to have the capacitor adjust. Buy the right air curtain for the installation height. It'll definitely help.
Okay, thank you.
Let me answer him and I can help you out here. So,
how reliably does a air curtain stop rain or snow?
No. Actually, he pointed on dust, on sand, right? Air curtains can't stop sand or ice from coming in. Snow, yes. But to answer your question, right, I have seen air curtains installed in cold places like Chicago, where you have snow right outside the entrance. Just because of the airflow, the air curtains are installed typically inside the building in a cold place. So it's going to keep blowing warm air on the floor, dry any of the snow and the condensation present on the floor. So that way, it will prevent. Firstly, it will prevent the cold air from infiltrating, and any snow that might come at the floor level, it'll be dried as well.
Do you find any change in effectiveness when switching from laminar to turbulent flow?
Oh yeah, so turbulent flow for thermal separation is no go. So most of the times we use the same air curtain for flying insect control and also for thermal separation. But the installation height is going to be different. So if you're going to get an air curtain for flying insect control, install it at a lower height, okay, you'll see a lot more turbulence when the air hits the floor. Better for flying insect control. But for thermal separation, you need to have laminar airflow. That'll be the best case scenario for you.
Thank you for the presentation. Question on the FPS typically seen for
Okay.
Effectively, or you and I, like, you have the air curtain,
Mm-hmm.
more possibly pressurized. Do you actually need that?
Okay, it's a two-part question. It doesn't matter if it's a man door or a loading dock door. The FPS you asked for, right? Let me turn FPM. This is what I understand easily. Air curtains are included in ASHRAE and IGCC codes as an alternative vestibule. One of the criteria that air curtain has to meet to be as effective as a vestibule for thermal separation is it has to have about 400 feet per minute of airflow at the floor level. Doesn't matter how high you install it. You can install it 10 feet, 20 feet, doesn't matter. As long as you have 400 feet per minute of airflow at the floor level. But in my opinion, even 250 to 300 is a little bit is ideal, but at least the codes say 400 FPM. Okay, that is when the pressure is balanced on both sides of the opening. Okay, again, based on what I have seen, anytime you have a pressure difference of greater than 5 Pascal or 0.02 inches of water column, the effectiveness of the air curtain goes down. So essentially, if you have a positive pressure, I wouldn't recommend using an air curtain for thermal separation. Okay. All right, let me go first here. Yes, sir.
You mentioned ozone. Fine question. What's your take on for UV LEDs and their effectiveness, and would you combine UV LEDs into it?
I don't know the answer to that. I myself haven't tested UV with LEDs, but I don't see any drawbacks with either technologies as long as the dosage of the UV is the same. One thing the lamps that we offer, or the lamps that most of the air curtain manufacturers offers, they do have 1 year of warranty on it. The effectiveness goes down. Even though you see the blue shine, the effectiveness goes out. But if you have a UV LED which can provide the same dosage, and if it has a longer life, go for it. And also the lamps that we have, it's not suited for on-off control. So typically it's on 24/7. Okay, it's not harmful for people who are working around the air curtain. Any reflected light it's not harmful. The effectiveness of the UV itself is only like a few feet. So, but if you want to turn it on and off, and if LED UVs have a better life, go for it. Yes, sir. Huh? The air can be sanitized. So, and cleaning it can be. There are instances where you can have air curtains on both sides of the opening, vertically mounted. You can have UV, the HEPA filters, MERV filters, all those technologies, and blowing across. Okay, so what it does is it also sanitizes this indoor space, but when you open the door, it can go to full blast and hit on the person walking across the opening. If there are any debris, it was pretty popular during the COVID time when people had, the idea was not to, there'll be some virulence and things on a person. The idea was to blow it off. Okay, it'll work, but there's no test that we are not able to prove one way or the other. But in theory, it seems to work. But you need to have air curtain all across. Just kind of, because you can have it on the hair too, right? So, or you can have, if you have air curtain only on one side, it's not gonna sanitize completely. Again, challenges that we have faced is, people just walk through the door. The air is gonna see them only for like half a second. You need to have some kind of a protocol where the person comes in, like an airport, they stand, they turn around. Once you do that, yes, in theory, it can definitely at least blow stuff off their person. How much that's gonna do to improving sanitation, that's a question that you'll have to answer yourself.
Mars Air have a booth.
Yeah, I think it's $47.50, I guess.
47.
Yeah, $47.50. Yes, sir.
When would you make your FPM higher than the minimum recommendation?
Flight control applications.
What was that?
For flying insect control applications. So for thermal separations, you don't need to have a lot of airflow. Typically, it's counterintuitive. We think more airflow is better separation. It's true for flying insect control, not true for thermal separation. There's another gentleman. Yes.
Yeah, for a restaurant application, what makes it NSF?
NSF certification has got to, at least as far as what I've presented, has got nothing to do with indoor air quality. What most of the air curtain manufacturers deal is for flying insect control. NSF has different standards, one for customer entrance, which requires 600 feet per minute of airflow, or service entrance, which requires 1600 feet per minute of airflow, and different airflow requirements for drive-through windows and all that. But that has got to do with only flying insect control, nothing to do with what we're speaking today. Okay. All right, anyone else? Great, thank you all. Visit our booth. If you have any other questions, I'll be there. I can help you out.